Hello, my name is Thomas. I'm going to demonstrate my third year project, the scientific calculator and 3D dimensional function visualizer. So the first part of the project was a scientific calculator, which basically supports basic functions, basic operations, and a few options like delete and clear the screen. So let's say try the simple equation 2 plus 3 multiply 4, it's 14, which gives us the result of 14. Suppose as well the function answer, which gives us the result of the previous operation. In this case it's 14, so the answer plus 6, which 14 plus 6 gives us 20. Suppose as well constant like pi, e, logs, so log base 10 gives us 10, natural log here you go, you can do like that, log e to the power of 1, roughly 1. The next part is the function visualizer, which can plot functions. So let's say functions, function 0, straight line in 3D is just like a surface. We can play with axis, so those values indicates x, y, and z axis, and this number indicates the value, shows the value from -1 to 1. So basically when you enter pi, it means the x axis will be plotted from -pi to pi. The same with y and z. So let's say pi to pi, and let's say function sine x. Here you go. Okay. So this approach led us to keep the origin always in the middle of the screen, which it's good because basically those three-dimensional functions are symmetrical. So it led us to plot them in a nice way. So that's the sine function, like that. It's plotted in 3D. If you want to do it just in one dimension, actually two, it's like that. Just one period of the function. Let's say different function. This time we'll use the power of 2 plus y to the power of 2. Let's say from -pi to pi. Y-axis, here you go, it looks like that. We can play with z-axis as well. We can change it to 2, which makes the picture slightly smaller. You can play with grid as well. Let's say 10. You can see the picture is less detailed. We can go for 60. Here you go. You can see finer grid. Let's power to the power of 5. Let's see, here you go. Like that. We can change. If you want to see less, we can see pi over 2. No problem. Pi over 2. Here you go. You can see it now. It looks like that. You can demonstrate different function maybe, just to show maybe square root, absolute value cosinus x plus cos y. Okay, same, here we go. So in this case we can see just the small part of the function. We want to extend it, so let's say it from pi to pi, and okay, from mine, see, it's look like that. Let's go further. Let's say multiply 3. Here you go. See, it looks like that. You can change the grid 30 to say it's kind of clearer. And maybe I'll demonstrate the last function. Let's say -1 x to the power of 2 plus y to the power of 2. We'll see, let's say 2, 2, 4. Here we go. See, you can see this function, but we're simply the part of the function because the rest goes to the infinity, because as we say it's
we divided 1 over x, so in one case it's 0, so it gives us the infinity, but we just display the part of the function. Maybe 5, let's see, here you go, a bit smaller. You can go 3 here, 3 here, here you go. Looks like that. We can change the grid, 10, something like that. We can go 40, 50, here you go. Something like that. So we can just plot different function. Maybe the last one. Which one might look good? And this one's not too bad. Cos absolute value x plus absolute value y. Okay, close the bracket. Multiply everything by absolute value x plus absolute value y. We'll see how it will. Oh, there's an error in expression. Where? Once again, cos absolute value x plus absolute value y multiply absolute value x plus absolute value y. This time should work. Oh, you see? The function looks like that. Just go, for example. Let's see how it looks. There will be only 10 of them. Something like that. Really simple. Sometimes it shows the function better than the final one. Let's say 100. Here you go. Look like that. So basically that's it. All functions of this calculator, and so thank you for attention and see ya.